Hello and Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5 from ED 2492A. We will discuss about sampling distribution of sample variance. So these are our group members: Nona Chah binti Ismail, Norida Rashida binti Ramli, Nur Salsabila binti Norizan and Nona Suha binti Muhammad Nasir. Our learning objective from this topic can be summed up as 3 learning outcomes. Firstly, finding out whether the variance obtained from the sample match the population variance. Secondly, a representative sample of the population will be used in order to obtain the population variance. And lastly, able to apply the concept of population variance to real-life scenarios.
So what is sampling distribution for the sample variance? Sampling distribution of the sample variance refers to the distribution of the sample variance that you will obtain from multiple random samples taken from the same population. It is a theoretical distribution that describes how the sample variance statistic varies across different samples of the same size. This is formula that we use this formula to calculate the sample of variance for each of these random samples. For our information, chi-square test is a measure of how much the sampling distribution of the vary from the sample mean. The sampling distribution of the sample variance is the distribution of this sample variance obtained from all possible random samples of the same size. It describes how the sample variance statistic varies from sample to sample. For the theorem, this is formula that we use, which is n minus 1 times s squared over variance squared. For our information, chi-square test just only used for sampling distribution of the variance.
Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Najah binti Ismail with matrix number 2023305281 and I will show you our first question. So the question asks to assume that a random sample of 30 employees has been selected from all employees in company A, which is known to have a standard deviation of 15. What is the probability that the sample variance will fall between 185 and 400? So, the very first step is to determine the information given by the question. The question given that a random sample of 30 employees has been selected and the standard deviation is 15. So, we know that our n is equal to 30 and our standard deviation, which is denoted as a sigma, is equal to 15. Also, as the question given, the probability of the sample variance will fall between 185 and 400. So, we can write as P as square more than 185 and less than 400. Next, we proceed to the calculation part. The formula is chi-square n minus 1 more than and less than n minus 1 times with s square divided by population variance, which is denoted as a sigma square. So we will get a chi-square with a degree of freedom 29 more than 23.84 and less than 51.56. The next step is to find 23.84 and 51.56 in the table of chi-square using a degree of freedom V equal to 29. Let's focus on this chi-square table. We can see that 23.84 lies on 0.70 while 51.56 lies on 0.005. And lastly, we can say that the probability of the sample variance falling between 185 and 400 is 0.705 as the total of 0.70 and 0.005. That's all from me. We will proceed to the next question.
Now let's proceed with another question. Suppose an English subject teacher wants to calculate the variance of test score for a population of 5th grade students, a sample of 25 students randomly selected, and the sample variance is determined to be 230. The teacher wants to determine the probability that the true population variance exceeds 400. On the question given, just like the previous question, the first step is to identify the crucial information or data, which is the sample of 25 students we denoted as n, and also the sample variance s square, which is given the value 230. The next step is to figure out what the question wants, which is to find the probability that the true population variance exceeds 400. So to avoid making a mistake, let's highlight the question first. Then we can write probability population variance, which is denoted as sigma square, greater than 400. Now, recalling the formula for calculating a chi-square statistic, which is chi-square equal to n minus 1 times sample variance divided by population variance. The third step is we substitute all the values given in the formula and calculate them. Then we get the probability of chi-square greater than 13.8. The last step is to determine this probability. Consult a chi-square distribution table with degrees of freedom equal to n-1, which here is 24. Locate the value 13.8 in the table chi-square distribution with 24 as degree of freedom, resulting in probability of 0.95. As this question mentions exceeds 400, we don't have to minus the result with 1. Therefore, the probability that the true population variance exceeds 400 is 0.95.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sasabila binti Nurizan. My student ID is 2023389825. So today I will solve the question 3, which is the IQs of individual at school were randomly selected. A sample of 30 students' IQ is randomly selected. Then, the IQ are normally distributed with a standard deviation is equal to 20. Find the probability that the sample variance are less than 300. So, let's solve together. Okay, the solution for this question is, based on the question given, the first step you need to do is, you need to identify the important information in the question, which is, given sample of students selected is equal to 30. The standard deviation here is equal to 20. Okay, as we know, the standard deviation is a square root of variance. So the variance here is 20 squared. Okay, then the sample variance given is less than 300. Okay, here we have a formula to find the probability of sample variance. So the formula is degree freedom multiplied by sample variance and divide it with variance. This is approximate to chi squared with n-1, or we call as degree of freedom. Okay, then we write P, which is probability, and then we put the bracket beside the probability. Okay, in the bracket we write chi squared is less than the formula that was given before. Okay, enter the all value given in formula and we start to calculating. Okay, then you will get probability of chi square is less than 21.75. Okay, as this question asks you to find the probability is less than the sample of variance, so we need to put negative in front of 21.75. Okay, and then it will become chi square less than negative 21.75. Then you need to find that the 21.75 value in the table of chi square distribution. Okay, for this, we get 21.75 in the chi square table is equal to 0.8. After we get the value in the table, you need to calculate the exact value, which is 1 minus 0.8 to get the probability of the sample variance is less than 300. We need to do 1 minus value of chi square table because it is less than symbol. And then the final answer we will get, the probability is equal to 0.2. I think that's all for this.
Next, the application that related with our life is, as example, factory produce a certain product and the quality control team takes sample from each production batch to assess the product's quality. The variance in the sampling distribution helps determine the consistency of the product quality. A smaller sampling distribution variance indicates the production process is more stable and reliable. Next, in medical, in a clinical trial, researchers often take random samples of patients from a larger population to study the effects of a new drug. Understanding the sampling distribution variance is essential to assess the reliability of the results. A higher variance may indicate the observed effect could be due to random chance rather than the effectiveness of the drug. So, as conclusion, we can conclude that the sampling distribution variance measures how much the average value of different samples can vary. As sample size increase, the variance tends to decrease, making estimates more reliable. Smaller variance means more precise result. It is crucial for constructing confidence intervals and conducting hypotheses in statistics.
That's all from us. Thank you for listening.